Now we're going to turn the focus back to Ireland again, and Tomás Ryan from Trinity College, who's a Lister Fellow. What year did you get yours, Tomás? 2020. And he's going to tell us, you're not allowed to go on too long about this stuff, how difficult it is to be a Lister Fellow and do research in Ireland.
Okay. Well, good afternoon, everyone. I'm delighted to be here. This is a wonderful event, wonderful venue for it, and I hope it's just the beginning of a conversation of how we can integrate the UK and Irish biomedical science community through the Lister Institute. I'm Tomás Ryan. I've been working at Trinity College Dublin for 9 years now. I received the Lister Award in 2020 and had a big impact on me, both practically and professionally. When I came back to Ireland, I'm not going to talk too much about my own career. I was educated originally at Trinity College Dublin down the street, but I was trained in the UK and in the USA, in real Cambridge and in fake Cambridge in Massachusetts. And when I came back to Dublin, I really wanted to do some interesting science in Ireland. And I'm often told indirectly and then directly by my colleagues that I'm part of the Back from America Brigade. And it's taken me a while to understand this. And I am very much in the Back from America Brigade, and I will be until I retire, because I like excellent science. I think excellent science is good, and I want to see excellent science being done in Ireland. I think it's better to do excellent science than mediocre science. I just think it is. And I think it's good for Ireland internationally if we do excellent science. And one thing that we have been good at in Ireland in the past is literature. And this is evident in our Nobel Prize success for literature. We have had 4 Nobel laureates in literature. And if you compare it to the UK, who have had 9, and I'm including immigrants and expats here, we have about 1 Nobel laureate for literature for every 750,000 people. Whereas laureates per million people in the UK is about 5 times lower than that. Okay, so we're doing something right in Ireland, and we like to be very proud of our literary figures, as long as they don't come back, right? As with many Irish people, we like them to be successful abroad, but we don't really want them coming back and telling us what to do. But with respect to Irish literature, one quote I like from James Joyce is that the Irish, condemned to speak a language not quite their own, have stamped on it the mark of their own genius and competed for glory with the rest of the civilized world. This is then called English literature. Now, when it comes to biomedical sciences, we're not so impressive. We have 1 Nobel Prize winner for physiology or medicine, and that's cheating a little bit because he's really American and in America, and the work was done in America, although he's a Trinity graduate. And I don't think there's another country on earth that has contributed more to biomedical science and the major turning points in biomedical science than the United Kingdom. I mean, it really is one of the most impressive things, I think, in human culture and in human history. And although the USA has become dominant in recent history, the UK still comes, in second place in an impressive and consistent way. And because we're modeled on British infrastructure for obvious reasons, I often think we need to be paying close attention to what the UK is doing right, because often scientists are working with comparable resources in the UK as we do in Ireland. But I also think it's useful to consider what happened in the 40s and why the USA took over. Now, the USA was already a very dominant economic power before the 1940s, but it wasn't a dominant scientific power until after. Germany and the UK were really dominating in terms of Nobel Prizes for all science subjects, but also in terms of any measure of scientific output in general. And it all changed in New Mexico. And the reason it changed was because the USA realized that being a dominant power meant being at the frontier of key existing technologies. And the British Empire understood this implicitly a long time before that. The problem I feel in Europe, and by extension in Ireland, and I could probably say in modern day England, is that we're considering science and research to be a nice to have, to be a bonus, to be something that we can boast about when we have the spare cash. In the United States, and now I believe in China, they see it as something that is of existential importance, as much as defense, and not just for economic reasons. And until we realize this in Europe, I think we're going to be going on an increasingly dangerous path. Now, I recently came across the Lister Memorial in London. I had passed it 10 or 20 times in my life, but I never looked at it. I didn't realize this was Lister's statue. It's on the top of north side of Portland Place, between Marylebone and Fitzrovia. And it's a really fitting, I think, a really fitting memorial to Lister's immense contributions to science and to surgery. Of course, he's most well known for introducing aseptic techniques to surgery. The survival rate for surgery went from 50% to 90% around the world within 2 years, simply because of Lister's discoveries. But he also contributed to general scientific understanding and scientific practice in medical thinking. And this is where science actually can influence literature, which I hope then also influences science. Because Lister, after studying in UCL, he couldn't go to Cambridge because he was a Quaker. After studying in UCL, he became a professor at the University of Edinburgh. And he contributed there greatly to revising the medical curriculum and to making it more evidence-based, working closely with his colleague, Dr. Joseph Bell, who was a very popular a medical professor at Edinburgh at the time. And they focused on modern clinical methods, strong emphasis on observation and diagnosis, and taught rapid diagnostic inference. And what I think is very interesting is that they overlapped at Edinburgh for about 8 years as teachers there in the medical school. One of their students was a young Sir Arthur Conan Doyle, who was lectured by Joseph Lister for at least 2 years, and by Joseph Bell for the entirety of his medical training. And Arthur Conan Doyle, of course, modeled or used Joseph Bell to model his conception of Sherlock Holmes. And this, I think, is very important. I mean, it's important for my science. It didn't just teach me when I was young about deductive reasoning, but more the creative use of abductive reasoning, realizing there is a world outside of what you know, and if something is real and you have the right question, it shouldn't be that difficult to find the right answer. It shouldn't be all dependent on having the right p-value. And of course, to take no one's word for it, which of course is the motto of the Royal Society. But I would argue that biology hadn't caught up with physics and chemistry until around the time of Lister. And what's interesting also is that Conan Doyle and Lister were contemporaries in Marylebone for about 3 years. Conan Doyle opened up his first practice at 2 Upper Wimpole Street, just across from Wimpole Mews. And he had quite an unsuccessful eye clinic where he spent most of his time writing the first Sherlock Holmes stories. And the plaque is still on the door. Joseph Lister lived for over 30 years around the corner in much more affluent quarters at 12 Park Crescent, just off Regent's Park. And I'm often in this area visiting my wife, who's a professor at UCL, and also because, I'm up there begging for money from the other crowd. But the walk from Conan Doyle's house to Lister's house is about 8 minutes. So I was wondering, had they ever actually met while they were living in London at the same time? Conan Doyle, of course, was a much younger man. And I can't find any direct evidence apart from being in the audience when he was lecturing in Edinburgh. But then it turns out that there may have been a Berlin meeting, and this is when Robert Koch was developing the germ theory. And of course, he interacted with Lister indirectly quite a bit in Berlin. And Koch also had an exuberant idea for curing tuberculosis, which turned out to be not very effective, but good for diagnosing tuberculosis. And the young Arthur Conan Doyle, when he was being an unsuccessful doctor/journalist, decided to show up in Berlin without a ticket and tried to break into the lecture, and was sent away, was jeered for trying to do this, and had to scavenge lecture notes from people who attended. And he wrote articles basically calling Coke a crackpot, criticizing the tuberculosis remedy. It was probably a bit over the top, but that remedy was disproved by other people in serious German science. And people have argued this is why Arthur Conan Doyle decided, perhaps too exuberantly, to leave medicine and research and go entirely into writing. Okay, that's just an interesting historical aside. My lab started in 2017. We were funded originally by the European Research Council, and my Lister funding came in 2020. Why is this significant? Because I got my Lister funding a few months after March 2020. And at the beginning of the pandemic, all my mice were killed, as all the mice in Trinity were. It was one of the more conservative reactions to the pandemic. So this potentially could have destroyed my lab, and it meant I had to find interesting things to do with my time for a while. But then the Lister funding came along and literally saved my lab. I don't know what would have happened if I hadn't had it. People say it's not a lot of money. If something happens to you like COVID and you're a slow mouse neuroscience lab, it makes a huge difference. Also, the network makes a huge difference. And I asked my daughter yesterday when I said, I'm giving this talk today, how should I describe the challenges of Irish science relative to English science? And she said, when she's 12, but she's quite precocious, and she said to me, well, it's just like English science, but worse. And I said, well, what do you mean? And she said, well, there's just not a lot going on. There's not as much going on, so that must be a problem. And I think that's a slightly unfair depiction of Irish science because there are many advantages of being here. In my first year, and this is the previous funder in Ireland, Science Foundation Ireland, which is now Research Ireland. In my first year, my lab went to a conference in Washington, D.C. in 2017. This is our annual jamboree of neuroscientists. 30,000 people meet up every year for a chat, and it's very important to attend. And we came back on the red eye from Washington, D.C. We came through passport control in Dublin Airport, and immediately after passport control was a 20-foot sign advertising our lab's work to everyone who was walking through Dublin Airport. The basic question is, what if you could recall every memory? This is the central focus question that my lab works on. And this is actually extremely encouraging. I can't describe how encouraging that is to my lab and to myself. And if you were ever to read the mathematician, I forget his name, the mathematician who worked at Bell Labs in the United States for decades, one of the world's most successful mathematicians. He wrote The Rules of Successful Science as he learned from observing the most active years at Bell Labs in New Jersey. And he said one of the most crucial things is to employ inversion, to turn every disadvantage into an advantage. And one of the main advantages of being in Ireland is freedom. We have a freedom of action, a freedom of initiative, a freedom of scientific curiosity, and I think a freedom from bureaucracy relative to our British colleagues that I hope remains the case. And I quickly recognized this and I decided to use this in the study of what I do, which is memory engrams. I'm interested in knowing how you store memories in your brain. I'm interested in knowing what is the difference that makes a difference between your brain before and after you attend this event. Where is that information? How is it coded? How do we read it out? How can we read information out of your brain the way we can out of your genome? This is the motivating question for me. But because I started my lab in Dublin, I was able to diversify my research right away, not wait until I was established, not wait until I got tenure in an American institution or I got my second big grant. Immediately, we started to diversify our research into every topic that interested me or my team. And we divided our research into 4 corners: the mechanisms of how memories form, how they change their function during forgetting, what happens during early development, and crucially, how do memories interact with our instincts across evolution? And this is my long-term interest in the intersection between memory and language. And I would not have been able to get my tentacles into these different areas of research as a young man were I working in almost, I think, any other country. And this was not a mess. We delivered on every one of these objectives. These are the receipts. On the left-hand side, you'll see our substantial empirical papers. And on the right-hand side, you'll see all of our theoretical framings of the landscape. 100% of these were published after my lab was started and primarily from work in my lab in Dublin. One of my favorite questions is, what is forgetting? I'm not going to have much time to go into the science today, but I just want to give you a flavor for it before I return to what I think we need to be doing to improve how science is being done, or at least enabled. Now, forgetting is often thought of as a nuisance, as something we struggle with. I'm sure I met you, but I'm not sure where. And we are used to thinking about forgetting as a problem, as a nuisance. But increasingly, my work and others argues that forgetting is actually a feature. It's actually something the brain is trying to do on purpose, to help you organize information and even to be creative. And if we didn't forget, we would be quite intolerable company. And also we would make inappropriate decisions because we would assume the world is exactly like we first experienced it. And of course, things change. But we also have unnatural forgetting, which is due to accidents, disease, drug misuse, aging. And this is a problem. We want to understand both forms of forgetting, and we want to understand them in both humans and in mice. We want to understand the fundamental biology of this, but we also want to be able to do something about these public health problems. And the key for me, I think what changed the memory field in 2012 was the identification of engram cells. Because before then, we were just looking at the biology that enabled memory, that enabled learning. And after 2012, we were able to identify the cells that were coding specific memories in your brain, to tag them, to follow them, and to ask what they're doing. And the way we were able to find engram cells amidst billions of neurons and trillions of synaptic connections was similar to what Sherlock Holmes would have done, at least what he did do in the scandal of Bohemia. So he was tasked with the king of Bohemia into retrieving a compromising photograph, this is before it was going on Twitter and everything, from Irene Adler's home. And Watson asked, how are you going to get it from her home? He entered the house dressed as a priest. And he said, well, I'm not going to search for the photograph. I'm going to have her show me where it is. He said, how are you going to do that? So he gets Watson to release some smoke into the house. And Irene Adler runs to the safe because, according to Holmes, when a woman's home is on fire, she rushes to the thing that she values most. And we've taken a similar approach, which, by the way, molecular genetics did for decades in the 40s to 60s, in letting biology show us where the information is. By hijacking on immediate early genes, which are basically just genes whose expression is a function of neuronal activity. Your brain cells are spiking, certain genes are turned on, we copy the promoters, we identify the cells that are probably coding for memory. And this work we did in the Tanagawa lab, 2012 to 2016, where I was a postdoc, some of the most enjoyable and stressful years of my life. We managed to identify the cells that were coding for memory, and crucially, we could functionally test their function. And if you walk into the neuroscience building at MIT, Susumu designed it as a contemporary art museum. There's a beautiful sculpture suspended from the ceiling, which is 100 gold-plated neurons arranged in different constellations. And we want to understand how neurons encode memory. So we captured them with these genes, and then crucially, we labeled them with optogenetic receptors. These are receptors that respond to light, but cause neurons to have action potentials. Basically, it's a remote control for brain activity, makes your brain cells turn on at the click of a switch by delivering a laser to the mouse brain. And if these are engram cells, would cause memory recall. And this works, and on the left, I'm showing you an example from a lab in Toronto. On the right, a lab in UCL in London. That's a memory for an olfactory experience. On the right, it's an instinct for a predator is coming. But actually, nothing is happening to each mouse. So we're activating an engram. On the left, the mouse believes it should burrow, so it does, based on the memory. On the right, the mouse believes it's going to be attacked by a hawk, so it undergoes a threat response. So we have a real-time control for behavior. And we can also implant memories into the brain, which is one project I was involved in back in 2013. But my main contribution was to apply this to forgetting, to apply this to both natural forgetting and unnatural forgetting, because any given kind of forgetting can be due to the fact that the memory is destroyed. I've taken a book and I've burnt it. You're never getting that information. Or possibly that memory is still in your brain, so the book is just misplaced in the library and we don't know how to find it. Now, this is important if we want to treat disease, also important if you want to understand what's actually coding for the memory, as opposed to coding for memory retrieval, which is a very different thing. And our logic was, if we could label the engram cells and then allow the mice to forget. On the left, we caused amnesia due to drug abuse. On the right, we caused amnesia using genetic models of Alzheimer's, because we can give mice Alzheimer's disease. In both cases, we found that we could rescue the memory, provided that we stimulated the engram cells that were labeled before the memory was lost. And what this meant for the first time was that the memory was not lost. The memory was still in the brain, but just not being expressed. Okay? And this has been reproduced by numerous labs around the world, and we've applied it to a broader view of memory. And we now think that forgetting is not actually a form of information loss. We think that forgetting, whether natural or pathological, of different variants, is due to the altered expression of information in the brain. And I'm particularly obsessed with one particular kind of natural forgetting, which we call infantile amnesia. Because only 1/3 of you will experience dementia, but 100% of you, I think, have experienced infantile amnesia. You don't really remember what was happening before you were 3 or 4 years of age. And I think this is possibly the most informative kind of forgetting. And we can study this in rodents, and people have been studying this in rats for years. My group is one of the first to study it in mice, because we can parallel rodent and human development based on endocrinology, hormones, and also developmental anatomical structures. So we know that the first few weeks of mouse life corresponds to infancy in humans. And we know they're adolescents because they start being able to have children. So what my first student, Sarah, started to do was to label infant memories in the rodent brain when they were tiny little pups, P17. And then we observed them losing those memories behaviorally. And then 8 weeks later, when they grew into adults, we would implant optic fibers into the brain so that we could activate the engram cells from when they were infants. And we asked what happened. And we found that in 3 different types of behavioral paradigms: fear conditioning, which is they respond to a context by freezing because they were scared there; object recognition, do they recognize the object; and navigating a maze to find the escape hole. In all cases, activating the infant engrams resulted in the retrieval of the infant memories in a mature adult. And then we wanted to understand, could we find natural cases where this is altered so that we could then look in humans? And we started to look at maternal immune activation, partly because I'm in an immunology department, but also because maternal immune activation is one of the major causes of autism in the human population. And we hypothesized that the autism behavioral state may reduce natural forgetting to infantile amnesia. And basically, we give viral compounds to pregnant female mice. They're not infections, but the immune system believes it's having an infection and launches an inflammatory response. And then we let the pups come out and we study the offspring and how they learn. And what we found is that the male offspring did not have infantile amnesia anymore, but their sisters did. Their sisters still showed normal infantile amnesia, but the male brain and maternal immune activation offspring, which is an autism model, retained infant memories for all 3 behaviors into adulthood. And Sarah then got obsessed with this and moved to being a postdoctoral scientist at the Max Planck Institute of Berlin in Germany, where she's now a group leader starting a few months ago, and decided to set up a human version of her task using what we call a human Barnes maze, which is a semi-virtual reality environment where infants from West Berlin have to basically find Corky, which is a toy that they love, in different places, in different contexts, under different conditions. And we train them when they're 18 months or 20 months or 22 months of age. We test them the next day to show there's a memory there. And then we look at their forgetting curve over a year. And this is the first prospective study of infantile amnesia in humans ever. Now, I can't do optogenetics in humans, right? It's just not going to fly, particularly in human infants, at least not in Germany. But there were some good things about March 2020, because it was an experiment that nature did for us. And we know which people got infected with COVID or not when they were pregnant, and they did not vaccinate pregnant women in Germany in the first 2 years. So we've established cohorts working with Claudia Buss in East Berlin, who's an expert in maternal immune activation in humans. And some of her cohorts then make the journey down to Dahlem in West Berlin, so we can look at the maternal immune activation case in human infants in our assay. This is the experimenter dealing with the child. The mother's in the bottom left because it's not fear conditioning. We don't use shocks. It's a fun task. And you can see the child is wearing an EEG cap, which allows us to record gross brain activity. And this study will be submitted in the next few months. It was profiled nicely by Science magazine last year, and this is Sarah. It would have been nicer if they'd accepted the paper, but you know, that's the way it goes. So this is part of a growing topic in my lab, which is to focus on neuroimmune interactions with memory. Just as forgetting is adaptive and not a bug of the brain, I believe that neuroimmune interactions are adaptive. We often associate them with disease because we see increased neuroimmune activity in late life, but it's also there in early life. And that's not for disease reasons. That's for development reasons. Neuroimmune interactions, I believe, are there to inform brain operations, not to disrupt them. And we have a broader sphere of research where we're focusing on memory for interoceptive experience, that we should be focusing on memory of metabolic changes, inflammatory changes, and infection, rather than memories of mazes and objects. Because as Rory Guinness pointed out earlier, for most of human history, we had child mortality of nearly 50%. And nearly all of that was due to infection and exposure. So we have been under selective pressure for probably 600 million years to be dealing with those things. And since we're learning that we're forming memories of those things, a lot of how we deal with these things is due to learned responses. And a lot of why memory evolved in the first place was to deal with interoceptive and inflammatory responses rather than just behavioral problems. Building on this, we're trying to create a general translational platform for studying embodied engrams in humans and mice. Because when you're studying immunology or metabolism, you get easy biomarkers in the periphery. You don't need to get into the brain. And you get naturally occurring interventions like infection, inflammation, cold exposure, which happen to humans. And by studying development, you get longitudinal data. Development is an experiment that nature does for you, and the organism is changing, and you get that information. So this work is because of the perseverance, commitment, and general trust of my original lab, who are all here. Some of them were recruited from Trinity, absolutely excellent students. One reason to be in Ireland is the students are really fantastic. But also many people who've come to Ireland to work in my group and put a lot of faith in me when I was a junior PI working in a place where there wasn't a lot of systems neuroscience going on. I think I'm the only systems neuroscientist in Dublin, if not the country still. But we've established a good community, a good culture, a good working philosophy. But I'd particularly like to thank these 4 people because they worked on the Lister project. Sarah Power was my first student, Erica Stewart, one of my second students, Louisa Zelka, about to graduate from my lab now, Antje de Boer, new student who started about a year ago. It was the Lister Institute that made our developmental work possible. Not only did it enable my lab to survive March 2020 and the following year, but it also really gave us confidence to invest in the developmental aspect of our work. And now I am considered a developmental cognitive neuroscientist, even by human developmental cognitive neuroscientists. And I never did developmental work before I set off my own lab in Dublin. And now this work has been funded just last year by Research Ireland. So Research Ireland funded our developmental work, which started in Dublin, which was really a gratifying moment in our development. And they're really a fantastic group of people. If you ever get called by anyone in my lab, you can almost take it for granted that I will give them an excellent reference. So now in the last 2 minutes, I think I have 2 minutes? Okay, so what's the problem here? Okay, we want to think of ourselves as an island at the middle of the world, right? And it's a nice idea. We do have leverage, but we need to step up and do what that actually involves. Having ambition is one thing, delivering on it is the second thing. And I'm going to illustrate what I think the problem is with the focus on the brain, but I think this applies to all of biology, right? If we take the brain, for example, brain disorders account for over €1 trillion of health expenditure in the European Union every year. And that is before we get into long COVID, okay? But the European Union is spending €500 million per year. That's through all Brussels-based funding mechanisms, including the ERC. Now, member states are not prioritizing brain research. It's hard to add it up, but if you add up all the neuroscience funding from individual member states, you're probably going to get at about 1.5 to 2 billion euro per year. So collectively, Europe is spending about 2.5 to 3 billion euro per year, all public funding sources, national and federal. And in America, they're spending 12 billion tax dollars per year just on neuroscience. It's 1/3 of the NIH budget. 1/3 of the NIH budget, which is 55 billion a year, goes just to the brain because they understand it should be a priority. And for some reason, neuroscience lags behind in Europe and also lags behind in the UK. Now, the same problem is true for biomedical science, right? The overall European biomedical science budget is about 1/3 of what it is in the USA. Now, if we look at health expenditure as a percentage of GDP, it's always going up. Of course it is. It's expensive to be sick. Things will go up in cost. And this is European increase in expenditure on research as a proportion of GDP, which of course includes private research expenditure. Not really keeping up with how much we're spending on health. And I said at a psychiatry conference recently, this is an insane state of affairs. And I was reprimanded afterwards. You can't say insane. Okay. And you're not allowed to say disease either anymore. It's condition. But I'm learning. I want to be a part of the solution. Now, however, if you look at research and development expenditure in China, this is what's happening, right? We are now number 3 in the world, and we've been number 3 since 2020, and I'm not bringing any conspiracy theories in there, but we have been number 3 since 2020, and we should all find this alarming. And if we look at individual countries, you can see the USA, of course, is still on top, the UK, not doing too badly. China, going to pass out the UK in a year or two. European Union, on average, already surpassed by China. Ireland, always struggling, always putting a brave face on it. And struggling even when we have a budget excess. We could be spending money on research, but we're just not doing it. And if you look at research and development expenditure across European countries, what you'll see is Ireland is basically down with Slovakia. I think on this one, where are we? We're between Croatia and Lithuania. Now, this isn't fair because that's GDP, and GDP includes foreign nationals. This isn't real economics, but you can do it per person and you get the same results. So this is I'm going back to 2019. The only reason I'm going back to 2019 is before Brexit, so that we have UK on the scale too. It's annoying now to compare things. UK is a pretty good country, but still only 1.76 of GDP. In America, it's 3.3. The only really high-performing countries are the Nordics, Germany, Denmark, Belgium, Norway, and Israel. So if we look at allocation per person, which is more accurate in the case of Ireland, because we get away from the leprechaun economics of having Google and Facebook and so on here, Ireland is still tying with Italy, well below the European average, okay? And there's no reason for this, right? We should at least be above the European average. And as Maria Lepton noted, the president of the URC, when she was here in Dublin last year, if Ireland tripled its research expenditure, and I don't mean private research expenditure, I mean just the Research Ireland budget, we would be number 1 in Europe. And to be number 1 in Europe would cost us going from currently 300 million a year on research to going to 900 million a year on research. We would be number 1 in Europe overnight. And just to give you a view of that, we're spending about 15 billion a year on the healthcare service. And every year our health minister has to ask for an extra €1 billion to make up their balance sheet, which on itself is 3 times the size of the research funding budget in Ireland. So if ever there was a weird dichotomy between how much we spend on health and how much we spend on research, I think Ireland is probably one of the worst cases for that. And I put this line here just to show if your country is below this line, China is spending more than you, right? So this is something that should alarm a lot of people. The UK is below this line, even though you're not on this chart because, decisions were made. Now, however, the UK is a wonderful model for how we could be doing things in Ireland, because if you look at the UK, not in a comparative way, I don't know of a better country that is so transparent with how it spends its money. And you can separate out the money that's going to government departments on non-research, what's called research, and money that's going to the private sector on research, but really it's just pork barrel politics. You can look at how much you're really spending on direct-to-researcher research and discovery versus applied. And the UK are spending about 3.4 billion pounds per year on proper research, right? Now, it is possible for Ireland to easily match that. It would mean spending about 400 million euro per year through just discovery-based frontiers research. And then you can give another 200 million a year to your applied research, which our government likes so much. And everyone can have their way. You can have your cake and eat it. It would only cost us 600 million euros a year, only doubling the budget. It is so doable. And we need to find a way of making it happen. Because then we can look at the output. And the output is even more concerning. So the NIH is producing the most publications compared to any research funder. You can see the Wellcome Trust and UKMRC there. And this is alarming because they're going down, of course, because of what's happening there. But also China is going up. That blue line is China. They're steadily increasing their publication output and in a rate that will almost become exponential. And I know many of my colleagues will say, well, they're not the same quality as us. And by and large, that's true currently, with 5 to 10 years. They will be publishing in Nature and Science as much as us, and then they will be able to change the rules. They won't be forced to abide by our rules of playing the game. So the question I'd like to put to you, which has been put by other people for defense reasons, is why are 500 million Europeans expecting 300 million Americans to pay for 75% of the world's brain research and biology, right? When there is no need for this to be the case. The economic return is primarily going to America. We're losing brain capital to America, although less so these days. And US is going to dominate the next generation of artificial intelligence. Now, the world is changing, and if I can leave this on a slightly positive note, we have seen very good noises from the European Union and from Ireland about trying to recruit people to Ireland. This is the right idea, but it has to be coupled with proper investment in university infrastructure and with research funding, or we're all going to lose. And I have to say, I don't disagree. I have caution when some people say politicians don't trust us. How can they trust us if they don't hear from us? Right? Talk to any politician. They hear from almost every other sector of society more than us because we just don't bother talking to them. And when we talk to them, we talk at them. We don't listen, we don't engage, we don't follow up, and we don't bring the organization that we bring to writing our Lister applications to dealing with serious people who are trying to run the country and have 1,000 other things to do. So we need to get organized, right? Otherwise, nothing is going to happen. And there are many ways of getting organized. And I really would encourage everyone to find a way to spend 5% of your time engaging with politicians through science communication with the public or directly with politicians or with special interest groups. And the key to this is collaboration, right? If you're an immunologist and you need to do an electrophysiology experiment, you don't go and spend a year learning electrophysiology on a sabbatical. You collaborate with somebody who knows because you have other things to do. Right? And everyone here is a professional scientist. So you need to find a way of using 5% of your time to collaborate with people who do this for a living and find ways to make yourself useful, to work with your different societies, and there are many of them, to engage with research, to engage with policymakers. And at the Federation of European Neuroscience Societies, our objective is to contribute to making sure that FP10 is doubled, that the ERC budget is at least doubled to 32 billion, and that we can have less restrictions, not more, on animal research throughout the European Union. This is us engaging on Brain Week, St. Patrick's Day also in the European Parliament. We were able to attract the attention of a lot of MEPs because we brought John O'Keefe with us. If you bring a Nobel Prize winner with you to see politicians, the politicians just come to you, and it makes it really easy indeed. And I'd like to thank my colleagues who've been working with me on the Advocacy Committee of the Federation of European Neuroscience Societies in Brussels. They're academics across Europe. Now, I went back to this art sculpture that you see in MIT. I mean, if you're me and you walk in, you don't look at this, you just have a stress response. But if you haven't done your postdoc at MIT and you look up at this sculpture and then you climb the stairs and look down on the sculpture from a very particular point of view, this is what you see. And what we're trying to emphasize here, I believe, is that the information is in the structure. And this is what we're trying to understand in neuroscience. How do we find how the brain is making sense of the structure of its neurons? Where do you go from biology to information? Why is this important? Because we are not going to catch up with LLMs in China or the USA. They've won that, right? Europe is not going to be able to compete. But the next generation of AI, which according to Demis Hassabis and others will need to come in 5 years' time, is going to be based on the brain. And that is something that I believe is going to happen in my lifetime, 60% probability. I think it could happen in the next 5 to 10 years. And it's up to us to decide whether that's going to happen in UK and Europe or not. And if it doesn't happen here, we're going to be at a serious strategic disadvantage for everything that's coming in the next 20 to 40 years. So thank you for your attention. Thank you for the question. I completely agree with you. I think that the biological sciences community in particular played an absolute blinder in the pandemic. And it's unfortunate that much of public memory is now still filled with whataboutery and conspiracy theories in the USA because of the current health secretary. And of course, one has to recognize that we didn't do that in 10 months. We did it 10 years before the pandemic happened because of fundamental research that didn't know a pandemic was going to happen. And if that hadn't, much of that happened in Europe, if that hadn't have happened before, if that wasn't supported for basic discovery research, we would not have been able to make COVID vaccines. And right now we would just be accepting a high level of COVID mortality and morbidity because we'd be living in that kind of world. So I think we need to make that case stronger and also not be so hard on ourselves sometimes in terms of what have we actually contributed. But in respect to making that point to politicians, I feel like we often think that if we say one really clever thing or make one excellent point, that they'll just go, oh, yes, here's the money, off you go. But dealing in politics is not like law or science. It's not like once you're proven to be right, you're right, and we'll remember that. It's just a cacophony of different voices. And the people who are out lobbying us in the private sector for how Research Ireland should use its budget, it's not that they've got a brilliant point. It's that they keep hitting their message again and again and again. And there's so many of them hitting the message again and again and again. And it's boring work, but it has to be done in an organized way so that they have no choice but to listen to us. So I think while the message is correct, we're mainly failing, I think, on the delivery of the message.